Hello, my name is Jonathan Nielsen. I'm in Data Analytics 30. I'm fond of math and board games, and I enjoy finding out why things are the way they are. So analytics felt like a good fit for me as a way of explaining why some things happen. My project is on travel data. During the pandemic, the total mileage driven by Americans dropped. However, at the same time, traffic fatalities went up. This is a little confounding analytically, as there's an obvious relationship between miles driven and accidents. So this analysis was an exploration of the data, an attempt to explain what's happening and why. Some preliminaries. The National Highway Transportation Safety Administration collects data on road fatalities, and the Federal Highway Administration gathers data on road usage to estimate vehicle miles traveled per month. So these are the sources from which I gathered my data. Least squares is a mathematical tool used to plot predictive lines from scattered data points. The t-test is a tool that helps provide an analysis in whether a sample could have come from another population. It tells whether two groups are related. A very low p-value means it's unlikely that they are related. The data I'll be using is joined from accident and travel data by state and date. Each dot here represents a state and date measurement. Here we see a least squares model for traffic fatalities. The best fit line suggests around 1.2 deaths per 100 million miles traveled. The r-squared tells us that this model accounts for about 91% of the variability in traffic fatalities. So this is a generally pretty good model. So let's see what happens when how our model predicts the outcomes of the pandemic year. Badly. The red is the predicted fatality rate, and the yellow is what was measured instead. So what's going on? First, we check if the crash rate is different in a statistically significant way from pre-pandemic times. By inspection, that's clear that the medians are not the same. And we also use a t-test, and the t-test gives us a p-value that's very small, so it's statistically significant. So satisfied that this is more than a blip, and that we move on to trying out hypotheses. One explanation is that not all roads are equal. State and national departments of transportation classify roads by function, and information about how dangerous those roads are is regularly published. Checking if travel on the better roads is the culprit, we unfortunately see that the box plots have nearly identical medians, and a t-test reveals that there aren't any significant differences between the two samples. Another possible explanation about road quality was the difference between urban and rural areas. Perhaps density of the areas would have an impact. Once again, while there's a slight difference between the means of the two samples, it's well within the range of chance. Unfortunately, sometimes hypotheses are incorrect. In this case, my hypotheses were that the road quality had an impact on the fatality rate that was observed. Unfortunately, that turned out to not be true. And in general, we just see a big statistical uptake that's not explained by travel data. This is what the Transportation Administration generally noticed too. Sometimes this is referred to as a black swan, something that just isn't predicted by other things, and unfortunately, sometimes there aren't satisfying explanations, and that's what my model ended up showing.